Okay, welcome back. We have two papers for the breakout session. And the first paper is by David Limbaugh, who's the director of the Soil and Plant Science Division. And Dr. Limbaugh will be speaking on the next steps in this division. So Dave.
All right, thank you. Make sure I can share my screen here and get the presentation up and running. And it's all, let's see, we have to display settings. All right, so hopefully you can see the presentation, and it's not the presenter's view, it's the viewer's view. So we want to talk about the dynamics.
David,
yes.
Sorry, I'm going to cut in here. We do not see the presentation. So we make sure that you have the screen share option that you checked it at the bottom on the right-hand side.
I did. Let me try that one more time. All right, let's try it now.
That we do see it. If you want to go ahead into presentation mode, it may just be a step behind.
Okay, how's that?
We actually see there, that's perfect. We got it.
All right. Technology is great when it works. So, and this whole presentation relies greatly on technology. So you've heard a little bit from several of the speakers already about dynamic soil survey. So what I want to do here is kind of give the overview of where we in the division are heading for the next 10, 15, 50 years. And that is the dynamic soil survey. Our next generation of using the resource, and not just so much using it, collecting the data, but getting it out to the people that need the data. So I'd like to start thinking about, wouldn't it be great if all the soils information was out there on a 10-meter grid or finer? You have properties to at least 120 centimeters, maybe deeper, and an accuracy of an estimate of the accuracy. For modelers, for planners, this is all going to be important, getting that resolution, improving upon it. We can then use that to interpret land uses. What can it be? What can this soil be used for? And how do we then affect that soil? Dylan gave a great presentation along with Zamir to talk about the issue of soil moisture. And granted, we may not be there yet where we can have real-time water and climate information presented to people on soil moisture on that 10-meter grid. But let's not be so concerned about what we can't do right now. What should we be doing? How can we get to that point in as quick a period of time as possible? As Dylan pointed out, there's a lot of information out there. It's not just our information. So, but wouldn't it be great if we could access that and use it? Then forecast what will happen as different practices are put into place for soil health, the dynamic soil properties, what Sky had talked about, water-based resource concerns, erosion, what will happen if, and then determination of effectiveness of these practices, using our state and transition models to help producers, help landowners, help land managers really get to where they want to be and see this in real time while they're working with a planner on their property and get an idea as to what would be best for them, best for the property, best for the environment. And it would all be done in one place, not going to 5 or 6 different websites, talking to 3 or 4 different people, but in one location, one app. So that's where we're headed. You will be able to do this. That's our goal. That's where we're headed in the next 5, 10, 15, 50 years. And this fits into really what our Secretary of Agriculture has been talking about. Fact-based, data-driven, science-based, and consumer focus. We can't forget that what we do is for the consumer. So keep that in the back of your mind. And this is going to be a cooperative effort. It cannot be done alone. So part of this presentation, I just wanted to point out, has been given to the chief. It's been given to the leadership within NRCS a 3 weeks ago. And this was the big rock from the Soil and Plant Science Division. We had a lot of help putting this together with our national leaders, our regional directors, and presented this view of how soil survey, ecological survey, the stuff that we do, fits into the big picture of NRCS. And really, one of the comments after the presentation that our deputy chief gave was, folks now saw how much we do within this division and how much it relates to everything else. We would have hoped they'd do that beforehand, but it really showed what we're doing. So we are indeed headed forward in this effort. So the dynamic soil survey, it's an evolving soil survey. We started off with the paper version. These are still great. I still use them when I teach kids Envirothon and how to use soil survey. We have web soil survey, kind of the next step. It's kind of hard to do some training though when not everybody has a laptop or a tablet yet, but we'll get there. But again, it's the next evolution, was going from paper to the web, and next is the dynamic survey. So this is a image that Dylan helped us put together, and it happens to be on a little farm in the Shenandoah Valley of Virginia. Our chief actually lives on this property, so we showed his farm, and it's a really good illustration of what we can do. Granted, this is a model and it does need to be ground truthed, but it's where we can be headed. So what is it? We're going to incorporate the spatial, temporal, climatic, biological data all into the soil survey, almost a one-stop shop. We've got to continue to work on the soil maps. We will be moving more towards the digital soil mapping. And again, but it's still going to require field work. The ecological sites, tying that into the soils, into the land use, into the state in transition. Dynamic soil properties, these are the things that change relatively quickly. As Skye pointed out, the aggregate stability, how quickly can that change? Does carbon change as quickly? What does it mean when it changes? How can we actually start to predict what could happen? And then, of course, tying in the climate and hydrologic data is going to be critical. We can't do it all, so that is where we are going to need our partners to help out. All throughout this, the dynamic soil survey is still not going to be sitting behind a computer and just manipulating data. It is going to rely heavily on field work, ground truthing, constantly updating the information that we have so that we have job security. It's going to be important to know that we don't know everything right now. There are areas where we have holes in our data. Several of the regional directors earlier this morning talked about the fact that there are still some areas that were not mapped that now they're able to get to. Some areas have been mapped many years ago, and through the eval projects, we're trying to get those joins so that we don't see where those lines are, that it becomes a seamless soil survey. We should be done with our ecological sites, the provisional ecological sites, this year in the lower 48. That is not the end of it. Now we go back, we tweak them, we update them, we get more information to improve those state and transition models. Dynamic soil properties are ongoing. We have to keep measuring them. We have to know how things change. One of the questions that I heard was, is 2 years of no-till equivalent to 10 years of no-till? Well, maybe in some places it is. We don't necessarily know that, but so that's part of the dynamic soil properties evaluations, is being able to evaluate how those changes occur and what they mean, and then pulling in the climate data. Several states have climate data. It just isn't accessible right now. Concurrent with this meeting is the National Soil Moisture meeting. So they're talking about how we can cooperate better. I mentioned this morning talking with the National Academy of Sciences about getting a meeting together that will talk about soil data. All of this is part of that. So getting our cooperators, getting more people to know where we're headed and how their data can help us is what we want to do. So one part of this kind of four-legged stool rather than a three-legged stool of dynamic soil survey is moving towards raster soil maps, a digital soil map. Specific properties will be assigned. We're going to rely heavily on field data and laboratory data to make these maps, as well as the remote sense data and model data. Of course, if you just rely on model data, there's going to be errors. We use the field data to change the model and so forth. So this is that it's an iterative process. We will never be complete. We will always be improving upon what we do. And that is not to say that the current polygon maps are necessarily bad. They're not. They have a lot of information, and we can't forget what information is there, but we can still add to it and improve upon where we are. So if we take a look, this is a farm, again, in the Shenandoah Valley. And this is what the web soil survey map would look like. And you can see the series there, the slopes, etc. And when we pull up the Surgo map, color code each one of the polygons, see how it lays out. But with a raster-based map, you can see it's a little different. So we've added more information. We've actually added in some information down in this section that wasn't originally there, and it's under my, part of my screen is hidden here, but you can see how more information has been brought onto the Surgo map by applying the digital soil mapping techniques. This should then help the producer better manage his or her land. We can look at the crop commodity index on this property as well. If we just base it on the Surgo map, we get one version. But if we look at the raster map, it changes. And this could change payments. This could change how that person looks at their land, what they decide to do in a given area. So it'll help the planner. It'll help the Farm Services Administration. It'll help RMA. So it'll help a lot of our sister agencies help the producer do a better job with their land. And of course, can't show this without talking about organic carbon. The standard Surgo map shows one view, the raster map shows another. So to where we're predicting what the carbon content would be in that surface layer. So again, changing the data, changing the resolution, again, hopefully helping the management. Dylan showed some of these slides, or some of these similar slides when we start talking about estimated soil moisture. And we all know, we've worked with soils, that you can estimate where the moisture would be, or what the probability is that you'll have it be dry or wet in any given time period. And you can look across the landscape and look at the various soil series that are mapped there and recognize that they each have a different model or a different set of estimated soil moistures. But taking that and then putting it together on the landscape. And again, this has not been ground truth. This is a complete estimate. It's a model. It would need to be ground truthed. But think of how a producer or how a land manager, whether it be in agriculture or forestry, or even in an urban setting, how this type of information, where they're looking at how that moisture content changes as a result of precipitation, they can start making some estimates on where they need to do different practices. So again, this is a great way to visualize what could be there. And now imagine if we can actually say, given the fact that there's a storm coming, this is what we would expect to have happen. All things that managers have been looking for a long time. As was pointed out earlier, we can also look at runoff and determine with a 1-inch rain in 1 hour, where will the runoff occur? Again, this is a model. It would have to be ground truthed, and that's part of our dynamic soil survey, is putting in the instrumentation to get the information that we need to take this approach and expand it nationally. State and transition models, the ecological sites, are also a component of the dynamic soil survey. Here, again, the example for the Chief's Farm, where we have either a forest, post-disturbance, or agriculture. And these arrows are the transitions. If you are in a forest and you want to move to a agricultural situation, what are the practices that you would recommend? If you are in an agricultural setting and you had, let's say, invasive species or a high amount of erosion, which conservation practice would be best to use on this land to give you the result that you're looking for? So it's tying in those ecosystem services, the resource concerns, the conservation practices to help do the voluntary management that NRCS promotes. But this way, again, we can limit in some regards what practices get discussed, so that we're not talking about every practice as being potential, but we're talking about the ones that have the most likelihood of being successful. That way we save the taxpayers money, we save the effort of the landowner, and hopefully everybody's happy. We can look at it in regards to using the ecological states to assess trends and conditions. So we know that in a given site, there's a certain ecological potential for the amount of organic matter that could be there. You cannot constantly increase organic matter. There is a threshold based on the climatic and soil conditions, landscape, etc. We know as soon as we start manipulating it, farming it, that potential may drop. So we may get where it is here, the attainable during grain production. And if we do nothing, this darker line shows what will happen over time. There's no time scale on this. Again, this is more theoretical. And we know if we try to do an alternative management, maybe we can not lower the organic matter as quickly. However, if we really hit into the best management, we can eventually get back to that maximum attainable when you're producing grain on that property. But if you do nothing, it doesn't look good. So again, these are showing the options. I think Mike Wilson talked about how when talking with folks about climate change, know what they're interested in, know your audience, and explain how to get where you want to go in terms that audience can best understand. So these are some tools that could be used using, again, our soil survey to demonstrate this. And pictures are always great. Looking at how deep tillage, you end up with one big clod. The cover crop, the more aggregation.
Yeah, so I think it's a 2-hour meeting.
Okay, so obviously we had somebody not on mute, which is okay. So so again, using and combining both what we expect and then how we can demonstrate that with photographs on a particular site is a great way to demonstrate what can be attained. But we of course have nice maps to show as well. So here, estimated of what the organic surface is using our Surgo maps, and then start to predict where we would be under different management. So if we go to use a raster soil survey and poor management, this does not look good. It's much lower organic matter. The poor management will lose organic matter from this site, and coupled, I would assume, less aggregate stability, less water hold, and more erosion. Under typical management, we look better, okay, but we're still in a relatively low range for the organic matter. Yet with better management or good management, you can see what we could attain on this site by changing our management, and demonstrating these differences with our dynamic soil survey is a great way to convince a landowner what practices to use and how to best manage their land. In order to make this work, I've mentioned it a couple times, I'll mention it again, we need to combine resources. I've mentioned the National Soil Moisture Network, working with the Forest Service, with ARS, with BLM, whomever, with individual states. We have to take what's out there and get value-added products. Our first step is working in Coweta. I believe Kevin Norwood mentioned that. That is a site in Western Carolina. Actually, it's in Dave Kingsbury's region. So we're working with them. We're working with Hubbard Brook up in New Hampshire. Both of them are experimental forests that have been instrumented for a long period of time. So by working with them, we're providing some of the soil data, they're providing the hydrologic data. We can hopefully start to get to where we want to go with looking at the soil moisture, the digital soil mapping, state and transition models, dynamic soil properties, and get to the point where we can have it all in one place. That's the overall goal. So as we move forward, we know what we can deliver today. We can deliver raster soil surveys. We can deliver interpretations. We can deliver state and transition models and pathways. We're constantly improving the soil data for priority targeted practices. This is what we can do this now, and we are. We're still supporting conservation practices, but precision conservation, precision agriculture, planning, the potential for soil health, and then CART. What we're talking about here with this type of approach will fit very well into the agency's newest product, CART, and help us become just an absolutely critical part of that whole process. Where we could go, what we should be able to do is eventually get that live interactive phone app or tablet app or whatever they might be in 10 years. Look at hydrologic soil groups. How are they going to change? Can they be more dynamic than simply having A, B, C, D? Real-time properties, how will they change? And then prediction, forecasting of how properties change over time. We did just get good news in that our dynamic soil property database is going to be developed. So we're moving in that direction. It's not going to happen overnight, but it is going to happen with all of your help. So again, the dynamic soil survey, think of it as the fundamental resource, the underpinning of what is done for land conservation within the agency. It helps us understand and works with our resource management. Definitely can help people look at soil health, identify, and predict where we may be going. Conservation planners need this in order to do that science-based approach to conservation planning. And could be a great visual to help producers understand what those practices could be doing. And it fits into some of our really big initiatives, such as Chesapeake Bay, as well as some of the wildlife initiatives. We heard about some of the wildlife earlier. How does our understanding of how soils change along with climate affect wildlife? These are all tie-ins that we have and that we will be exploring and expanding upon within the dynamic soil survey. So a lot of folks contributed to this. My name should probably not be on it, although I'm talking about it, but these are the folks that really put this together. they're given a task to put a presentation together for the chief in 2 weeks. They did a fantastic job. Folks have now seen this really several times across the country. So we are headed in this direction, and I'll be happy to take any questions. So I'll go back to there. So if there are any questions, let me know.
Okay,
I
Dave,
do
you
not
do
have
have
any
one?
questions in the MUConf9 email.
Okay, there's one that came across the chat, and Dave, you can probably read it if you just click on your chat.
No, I don't. I click on chat. Hold on a second.
Okay.
No,
I'll read it to you.
appreciate that. Go ahead.
Okay. How do we validate these proposed dynamic soil moisture models? Can the existing soil climate analysis network scan be used or expanded to support the proposed dynamic soil survey? Thanks.
So the answer the second part of the question first, absolutely we need to tie into scan. How we're going to validate it beyond that, we will validate it in any possible way that we can. Use whatever data is available. This is, again, Dylan said it is complicated, and it is, because we don't have all of this necessarily in place yet. But if we were going to wait until we had everything in place, we might never get there. So now that this is where we're headed, if folks have ideas, how are we going to do it? Let's talk about it. Let's get the information out there. Let's talk about best ways to validate it. These are good research questions as to how we can take knowing where we want to go, figure out how best to collect the data, validate the data, model the data, refine the data, and deliver it. It's all part of the vision. But great question.
Okay. Well, thank you for that presentation. I see no more questions, so we'll move on then to our next speaker, which is Dave Hoover, the director of the National Soil Survey Center. And Dave will give an update on the center. Dave Hoover, take it away.
Thank you, Curtis. I'm good as far as display, Jen.
Yes, you are.
I learned. I practiced too. Hi, it's great to be here at this conference. It's great to be out of Lincoln a little bit and over to Missouri. It's lovely over here this time of year. I wanted to talk today about a perspective from the National Soil Survey Center. I want to talk about some current things, some new things, some things we're going to be seeing in 2021, and also hopefully have a little bit of time to talk about some things on out a little bit further than 2021. So we do have some familiar faces and some new roles here at the National Soil Survey Center. We have folks like Deb Harms, who is our new national leader for the Soil Science Laboratory. We have Sky Wills, who is the new national leader for Soil Science Research that we just heard from. This is also first time in quite a number of years we've separated and had two national leaders, one for research, one for lab. And we want to strengthen and grow our research program. We also want to strengthen the operations in the laboratory. So we thought a good way to do it is to have two national leaders. They work well together. They work well with the rest of us here at the center too. We have Kevin Leffelman, who is a new lab scientist, was a term employee, and now is full-time with us. We have two new management analysts on my staff, working in some new capacities. We have Linda Kruger and Linda Boats, who are doing numerous items every day. We have Kyle Stevens, who is our new, been around for a little while, but probably new since the last time we had one of these North Central conferences. Kyle Stevens, who is our National Database Manager, and we have Suzanne Keenest-Brown, who is our National GIS Specialist. So great to have some skilled folks in some needed positions. Some of the things that we're going to keep working on. One is soil map refinement. We saw some examples earlier. Somebody put up a regional soils map, and you can still see it was dense in some places, dense lines and polygons in some places. Survey is not matching, so we need to continue with our digital soil mapping and digital soil map updates. We need to be able to train in that. We need to be looking at new methods for aggregating and scaling our digital soils data. And we need to be able to provide not only support to existing operations, but looking into new operations that can go on. Our data is used by more and more people these days. The more people that use our data, the more ways they look at it, and the more ways we find that we could strengthen our data population or our data gaps in some places. So we know that for certain conservation programs that there are some data that are used frequently. We need to be able to identify those and to get them updated in all parts of the country. We need to provide data to more people faster, better, quicker, more intuitive, all sorts of ways to get the information out to people. So we are modernizing our everything from the NASA's data structure to soil data access to web soil survey. And we want to be able to connect all of our soils information, the soils data, the ecological data, the laboratory data, and not have separate databases that somebody has to go to 3 different ones in order to collect information. Our laboratory never stops. We have the traditional methods that have been done for a long time. We have new ones that need to be identified, such as new biological assessments. So we need to have the newest and latest machinery. We've seen some of these that we're getting out to field offices. Chad Remley, I think, had that in one slide with an MIR setup. I'm not going to go through each one of these machines, but they will be in the materials presented. Know that we're looking at new technology out there. And we're looking at new technology because we're continuing to provide chemical and physical analyses to the strengths that we have before, but even adding some more now, especially in the soil health arena. But we don't have a lot of biological analyses that we run. So we want to increase that, and we want to increase biologic research. So we will be hiring a biologic research soil scientist, hopefully this year. So that will be progressing on into next fiscal year for development of that position. I mentioned a little bit about the modernization process. We've been using these software, we've been using NASA's, we've been using Web Soil Survey for a lot of years. And it's really testament to the people who built those to begin with, that they still run. Yeah, we got some issues with them every now and then, but they're still operating. But they're using some technologies that need to be updated. So we're entering into a process of modernization like we haven't done for 15, 20 years. And it's time, and we've got support by the agency to do this. We've got funding even in some places to do this work. So we're going to continue to do modernization. One thing that we're doing, and you can see by these terribly complex process diagrams, is we're looking to see where all is soils data used in all of the over 200 different applications that this agency supports. So if a program is going to be changed that calculates dairy effluent pond size, something like that, if it needs soils data, we want to make sure that we have a soils data delivery system that will support that new application, so that we're not always just funding the newest and shiniest applications out there, but we are funding all those other systems that get data to it and that use data from it. So we're looking at a more holistic approach to how all of the software data that we have out there are related and what their dependencies are. We're going to be putting out a new plants version 3 database and website. Going to be doing some improvements that have needed to be done for quite a few years on that. And I know all of you use plants out there, but I want everybody, I wrote out what the actual acronym stands for. It isn't just about plants. It is about plants, but it also is an acronym for the plant list of accepted nomenclature, taxonomy, and symbols. So that'll be the test next session to see if everybody remembered that one. Anyway, lots of good modernization with the plants data set. Here's an area that I know is going to start getting a lot more use in the agency. As been mentioned before, that we are populating the EDIT site. And I'm not going to say EDIT database here because EDIT is a decision support tool that just happens to have this tremendous ecological database as part of its back-end information set. So ecological data is going to be used like never before by this agency in ways that this agency hasn't used it before. So hopefully this will carry through. We're doing a lot of work with other federal agencies on the utilization of our ecological site information. And we are continuing to work on a global level. We're working with the UN, with the Food and Agriculture Organization, through things that GLOW. So GLOSIS, the Global Soil Information System, that will allow other countries to talk to each other with their information systems about soils. GLOSOLAN, which is the Global Soil Laboratory Network, which is going to allow standardization of lab procedures. So we are involved too. This strengthens us to be able to work on a global level because we don't know everything there is to know about every soil in the nation or in the world. So by knowing what other countries know about soils that we may have in the United States, we can increase our knowledge. And we're going to continue in the coming years to build collaboration with new partnerships. We work with the FBI with soils as a forensic tool. We're working with the oyster industry, with road safety organizations. We're building new strengthening relationships with Hispanic speaking institutions. We're working with the CDC on disease transmission through dust. So more people are coming to us and we're making our data more available to others. We had a good presentation this morning from Dan Wing on the revisions to the MLRAs, so I'm not going to go into great detail on that, other than we're really looking forward for a revision for this. It's been a while. We're currently working on and will be completing this fall a document showing a new level of involvement between the Soil and Plant Science Division and the SCAN network in the United States. Currently, the SCAN network has about 220 SCAN locations for soil climate analysis network stations. There's also a huge mesonet of other climate stations that have soil moisture and temperature information on them. There's also a network of soil scientists out there. So here's a marriage that's just looking to happen in there, and the Soil and Plant Science Division will be taking a more active role in the maintenance of SCAN sites, of the citing of SCAN sites, and in the data quality of the information that comes from them. I had to throw this in there. I really like these maps. Don't know if you know they're all available. Just happens to be a Missouri one I have on this slide set. But here are soil color maps of all the states. So this emphasizes all the information that comes out of the National Soil Survey Center that is shared with states, with soil scientists, with others. So we're taking a pretty active role in getting information and training out to all the states. So that's my quick talking version of some things that are happening in here. I wanted to talk just a little bit too about the not so near future of soil science. So we talk about what's happening in the next 10 years, or we talk about what's happening next year. But I think it's important for us as soil scientists, natural resource specialists, to look what's happening out there 20 years into the future, or to think about what could be out there 50 years out into the future. If we don't start planning now for what's going to be out there in generations to come, we're not going to be prepared to take it on when we have opportunities. So I think we all have to start thinking about what do we want to see in soil science in 50 years? What's it going to look like out there? I'll give you a couple of my favorite ideas. So I always liked the tricorder. I think this is was a great invention. It gave the guys on Star Trek information about everything. And they didn't have one separate tricorder for this function and another separate tricorder for that function. They had the tricorder, and it gave them information. We're not far from that now with handheld and portable and smaller devices that give us information about metals, gamma rays, color, conductivity, soil property predictions. Putting all this together into one soils tricorder, I don't think is going to be that far out into the future. And we're going to have more, a single tool out there that will give us greater functionality out in the field. So I'm looking for this one to come soon. I also think that we're going to be seeing in some year out there, depth penetrating satellite sensors. Right now we have a lot of superficial sensors that are out there, or atmospheric sensors. We have some sensors that can detect soil moisture down to a few centimeters in depth. I'm ready to see it go down a meter in depth and give us information. I don't accept anybody that says, well, they just don't go down that far, or they get turned back by the mineralogy of the soil. I think this is going to be overcome in some coming year so that we can get Earth coverage to depth from our satellites. The other thing I want to see is I want to go out to any part on the land, and I want to stand there and I want to get a subsurface hologram of what's underneath my feet. I don't think that's too far off either. I think that can happen. I think it's important when we're doing field investigations. I love digging holes. I've talked to my family. I'll just give me a spade and a shovel and I'm a happy camper. But I think we can go beyond that and get quicker estimations and quicker visualization of what's under our feet in a holograph, handheld, on site. So those are just a few of my ideas of what could be happening out there. And just wanted to share that with you and hopefully get y'all to expand your minds a little bit and think about what soil science could look like in 20 to 50 years out. That's all I have. Questions in the comments, or here's my contact information. And I'd love to discuss the current state or the future state with y'all anytime. Curtis, back to you.
Okay, Dave, thank you very much for that. And whenever a lot of this happens, remember where you heard it first. So thank you for that, Dave. Are there questions for Dave?
I do not have any in the MU-Conf email address.
Okay. All right, well, feel free to contact Dave if you do have questions that you think of. And right now we are scheduled to go to the breakout sessions. And how do you do that? Well, if you go back to the email with the agenda and the links, you have a choice of several breakout sessions to attend. And you can go to one, stay a while, leave, and come back out, and then go to another one. So with that, we'll break. But before we do, I just want to say that tomorrow we begin at 9 o'clock with a talk on the advancement of soil health assessments. So please join us at 9 in the morning.
Curtis,
Thank
I'm
you.
going to jump in here real quick. I did put the link to the agenda in the chat. So there is a direct link there if you wanted to kind of click on that. This room will remain open if you needed to come in and had a question. But reminder that there is a password associated with those breakout rooms directly, and that password is embedded within that code, but it's also listed. So instead of entering a waiting room, you'll enter the password and you'll go directly into the meeting.
Great. Thank you, Jen.